Please get out your Unit 8 notepad and turn to page 1. So this is Unit 8, Chemical Reactions and Chemical Equations. So we're going to follow along and fill in our notepad. A chemical reaction is a chemical change that forms a new substance. Some examples of chemical reactions are rusting, burning, and cooking an egg. Chemical reactions are described with chemical equations. So, parts of a chemical equation. The reactants are found on the left side of the equation, and they are the substances that will react. The products are the substances that are produced, and they are found on the right side of the equation. When you see an arrow, that separates your reactants from the products. The arrow stands for yields, forms, makes, produces, etc. So anything you see on the left side of the arrow will be considered a reactant, and anything you see on the right side of this arrow will be considered a product. A catalyst is a substance that speeds up the rate of a chemical reaction, but it's not actually used in the reaction, and you typically see it written above the arrow, such as platinum written right here. The point of this is to speed up the reaction. Bottom of page 1, let's label the parts of the reaction below and know the meaning of the symbols. So first of all, let's look at these symbols over here on the left. If you see an S in parentheses, such as right here, that stands for the solid phase. So that means that this silver is in the solid phase. If you see an L in parentheses, then it's in the liquid phase. So here, this L means this water is in the liquid phase. If you see G, that stands for the gas phase. So that G right here means this hydrogen is in the gaseous phase. And then CR is going to stand for crystalline, which is another way of saying it's in the solid phase. Now, I'm going to put a star next to AQ because that stands for aqueous, and it's the most common symbol that you're going to see. It means that you have a solution because the substance has been dissolved in water. So this one right here, because it's labeled AQ, that stands for aqueous, and that means it's a solution. This substance has been dissolved in water. Okay, the arrow is our yield sign, and you might see words like yield, form, produces, or makes, which indicate that we have the yield sign. A reactant is anything found on the left of the yield sign. A product is found on the right of the yield sign. So over here, and I'll get a different color, everything over here is going to be a reactant, and then we have our yield sign, and then everything over here is going to be a product. So we have two reactants, and we have two different products. If you see a triangle above the arrow, such as here, that stands for heat. It means the reaction needs to be heated in order to proceed. So you'll see we have the triangle above the arrow here. That means that heat has to be applied to these reactants for them to form the products. A coefficient is going to be the big number in front. So I'm going to just color code for you that the coefficients are found here, 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 and here. Notice we have a coefficient of 2 right there, but the other blanks, since they're empty, we're going to assume that they are each a coefficient of 1. So it's okay to write the ones, but if you don't see it, assume that that's what it is. And then lastly is the subscript, and I will color code that one for you also, that your subscripts are these numbers down low. So that 2 there, that 2 there, that 2 there are all subscripts. And if you don't see a number, such as right there, then you can assume that's a subscript of 1, but we just don't write the ones. Take a moment and see if we can identify which of the following compounds below is or are solutions. So pause the video, take about 1 minute, see if you can identify which of these are considered solutions, and then we'll unpause to see the answer. You should have chosen letters A, B, and C, but not letter D, are all solutions. And how do we know? When you see the AQ, that means it's a solution. It stands for aqueous. So AQ, aqueous, that's a solution, and this is a solution. But that is labeled S. That means it's in the solid phase, so it is not considered a solution. At the top of page 2, chemical equations may be written in two ways. They could be skeletal or balanced. Right now, we are just going to focus on writing skeletal equations. And this may also be stated as translating equations, where we're going to take an equation and we're going to translate it from word to symbol. A chemical equation that does not include the relative amounts of reactants and products involved, that means it is not balanced, is a skeletal equation. So when we write a skeletal equation, we have two things to consider. Is it a compound or is it an element? If it's a compound, are there any prefixes? If yes, use them. If not, we're going to use charges. If it's an element, the only question is it a diatomic? If yes, it needs a subscript of 2, and if not, then it does not need a subscript. You'll need to memorize these 7 elements as being diatomics that will need a subscript of 2, and then every other element will not need a subscript. So, here, for our first example, we have aluminum chlorate. Is that an element or is that a compound? Aluminum chlorate indicates 2 or more elements together, so this is going to be a compound. So, does it have prefixes? If you recall, the prefixes are as follows: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. So, do we see any of these in aluminum chlorate? No, we do not, and so we do not use the prefixes. That means we're going to have to find charges, and we're going to have to crisscross them. So where do we find charges? We go to the periodic table and to our reference chart. First, let's find aluminum on our reference chart. So if we look here, aluminum is there. Its symbol is Al, and it has a charge of +3. I'm going to write the symbol here, and I'm going to put its charge above the name. Now, we need to go find chlorate, and to do so, we're going to use our star reference chart, this one, and we're going to look under our polyatomic ions list. So chlorate is here, and it has a formula of ClO3, so I'm going to write that here, ClO3, and it has a charge of -1, so I'll write that here above the name. So now that I know what aluminum and chlorate are, now the question is, what are my subscripts going to be down here? And I'm going to use a different color to show this. So we're going to use the charges to figure out what are the subscripts, and we're going to do it by crisscrossing. This 1 means that we have a subscript of 1 for aluminum, and this 3 gives chlorate a subscript of 3. So I need a subscript of 1 here, and I'm going to need parentheses and a subscript of 3 here for chlorate. Because it says it's a solution, we can also put that this is in the aqueous state. Okay, it is heated to produce. When you see words like to produce, that is when you're going to draw your yield sign or your arrow. So now I'm going to draw my yield sign, and it also said it was heated, so I can put a triangle above the yield sign. Now we are producing a solution of aluminum chloride. So now let's focus on aluminum chloride. Is it an element or is it a compound? Well, aluminum chloride indicates 2 or more elements together, so it's going to be a compound. Are there any prefixes in the name? Do you see any of those prefixes like mono, di, tri, tetra, penta, hexa, octa, nona, deca? No, you do not. So we are going to use charges and crisscross them. So now we're going to do the same thing here as we did over there. Go find aluminum on the periodic table, and when you find aluminum, it's here, and it has a charge of +3. So we're going to write the symbol for aluminum there, and we're going to write that it has a charge of +3 up here. Now I'm going to go find chloride, and if you have an "ide," then that means that it's a negative ion on the periodic table. So it's in this section here. Chloride is there, and it has a charge of a -1. So we're going to write Cl, and then up here I'm going to write that it has a -1 charge. Now I'm going to crisscross the charges in order to figure out my subscripts. Aluminum has a subscript of 1 and chloride is going to have a subscript of 3. So this will be Al1Cl3. Notice I don't write the 1 here. And then also because they say that it is a solution, we can identify it as AQ or aqueous. Finally, we are here, and you see the word and means that we're going to add a plus sign. So we're going to put plus, and then the last thing we have is oxygen gas. Oxygen, is that a single element or is it a compound? It's a single element. So I'm going to write O, and the only question if it's a single element is it one of the 7 diatomics? And you will notice that here is oxygen there, and so yes it is, and therefore it needs a subscript of 2. So I'm going to put a little 2 here. And then because it's a gas, I can put a G in parentheses. And this is going to be the skeletal equation from this word equation here. Now let's write skeletal equations for the following word equations. We'll start with this one. First, we have hydrogen gas. Is it an element or is it a compound? It's a single element. And so the question now is it one of the diatomics? And it is one of our 7 diatomics. So when you write it, it has to have a subscript of 2. So we'll write H2. Okay, reacts with means put a plus. So we'll write plus. By the way, this says gas. So we can write a G in parentheses to indicate that it's in the gaseous phase. It's going to react with oxygen gas. And so the question is that a compound or is it an element? It is a single element. And so is it one of our diatomics? There's oxygen there. So yes, it's going to need a subscript of 2. So we'll write O2 and G for gas for oxygen. Now it says to form. That's when you draw your arrow. So we're going to draw an arrow. And then it says liquid water. Liquid is the phase, so I can put an L in parentheses. It's going to be at the bottom right. You want to always put these phase notations last after your compound, not first. And then water is H2O. That's a compound, so we are not concerned whether or not it's a diatomic. Notice the hydrogen and the oxygen. These are only going to get subscripts of 2 when they are completely alone as single elements, but when it's a compound, we use charges or prefixes to determine the subscripts. So do not use this rule here because this is not an element, it's a compound. Alright, and then this would be the final answer for that first one. So if you want, you can pause the video and try this one, and then we'll go over it together. So first we have aluminum metal, and the question is it a compound or is it an element? It's an element. Is it one of our 7 diatomics? No, it's not. So it's not going to get a subscript. We're just going to write Al and leave it at that. Remember, this is not a compound, so I'm not going to go look for charges. Okay, reacts with means put a plus sign, and if you want, being a metal, it means it's going to be in the solid phase, so we can put that, S for solid. Alright, we're going to react with oxygen that's in the air. So oxygen, is that a compound or is that a single element? It's a single element. Is it one of my diatomics? Yes, so it needs a little 2 next to it. So we're going to write O2 for oxygen, and it's in the air, so we know it's in the gaseous phase, so we'll put a G for gas. Now the words to form mean it's time to draw your arrow, your yield sign. Okay, and then we're going to make solid aluminum oxide. So solid means I'm going to have an S after my compound. So I did just answer this question. Is aluminum oxide an element or is it a compound? It's a compound. Does it have prefixes? No, it does not. It does not have any of these prefixes right here. And so that means that we are going to have to get the charges and crisscross them. So where to find aluminum? You're going to go look on your periodic table, and you're going to see aluminum here, and it has a charge of +3. So I'm going to write Al for aluminum, and up here above the name, I'm going to put its charge. Now, oxide, I'm going to go look in the I'd section of my periodic table, and there's oxide, and it's going to be O with a -2 charge. So here I'll write the O, and up here I'll write the -2 charge. Now, we're going to crisscross these charges to determine the subscripts. The subscript of aluminum should be a 2, and the subscript of oxide should be a 3. So this should be a 2, this should be a 3. We're going to crisscross to determine the subscripts. All right, pause the video and try the next one. Lithium, is that a compound or is it a single element? It's a single element. Is it one of my 7 diatomics? No, so it does not get a subscript. We're just going to write Li. Plus is telling you to put the plus sign, and we're not going to worry about the phase notation since they are not stating specifically what it is. Now we have oxygen. Is that a compound or is that a single element? It's a single element. Is it one of the 7 diatomics? Yes, so it needs a subscript of 2. So we're going to get O2, and now we're done with that. Produces. Now it's time to draw your arrow. Now, finally, we're at lithium oxide. Is that a compound or is it a single element? Lithium oxide. That's more than one element, so it's going to be a compound. Does it have any prefixes? It does not have any of these prefixes. Therefore, you need to go get charges and then crisscross those charges. So, lithium is here in the first family of the periodic table. So it is Li is the symbol and it has a +1 charge. So I'm going to write Li down here and I'm going to write that it has a +1 charge up there. Now I'm going to go to find oxide, and ide is in the ide section of the periodic table. There is oxide. It has a -2. So I'm going to write O here and -2 up there above the name. Now let's see if we can crisscross directly down into our formula. This means that lithium should have a subscript of 2, and this means oxide should have a subscript of 1. And so I'm going to leave it just like this. Let's do the final one. Pause the video and then watch the answer. Phosphorus is the first thing in our equation, and is it a compound or is it a single element? It's a single element. Is it one of your diatomics? No, so it does not get a subscript. We're just going to write P and we're done for phosphorus. Plus means put a plus sign. Now we're on to chlorine. Compound or single element? It's a single element. Is it one of the 7 diatomics? Yes, it is. So it's going to need a subscript of 2. So this is going to be Cl2. Now produces means to draw your arrow here. And now we're on to the final compound, which, as I just stated, is a compound, not an element. It's a compound because phosphorus pentachloride is 2 or more elements that are combined. So phosphorus pentachloride, does it have prefixes? Yes, it does. So the prefixes are the subscripts. There is no crisscrossing. So first, let's write the symbols of our elements. Phosphorus is P, chloride is Cl, and now, because this has no prefix in front of it, it has a subscript of 1. Because this has a prefix of penta in front of it, this has a subscript of 5. So this compound is PCl5. Concludes the first section of the notes. You should turn to the page 13 in the back of your workbook, and you should be able to do part 1, write skeletal equations for the following chemical reactions, in the homework section.